Okay, this is 3.3, absolute value transformations. It's not talking about the parent function absolute value. It's talking about if I take the absolute value of a whole function, if you see on this first one, or absolute value of just the x of that function. So what I want you to do is on your notes, you have the section 1, 4, 7, and 10. I want you to go ahead and do the transformations. I'm going to stop the video, write down what kind it is, and if there's asymptotes, you need to write all that stuff on each one as we go. And that way we'll come back and we'll use that to help us with this lesson. Okay, so this first graph looks like this. Quadratic, vertical shift down 3, horizontal shift to the right 2, and then the little blue that I have dots, the points in there are my original. And again, you don't have to write the points down, but I really think when it comes to reflections and such, it really is more helpful to do that. So what I'm gonna do is we're just gonna go back up to the notes. I'm just gonna give you a quick glance of each one of these before we do that. So my next one is the cubic. It's a vertical shift up 1, reflection with a y, so the x, y values changed signs. So I wanted to make sure, because I do have a tendency of reflection to make mistakes, and I want to always help myself by looking at the points, because that really helps me. So the green is the original, the red is the shift up 1, and then the black is more reflected. And you see that I changed the values and be able to look at them, the points. Next one is a natural log. It's vertical shift to 1, up, a horizontal shift to the left 2, and a vertical asymptote of x equals -2. Okay. And then the rational one. I had a rational horizontal shift to 2, a vertical shift down to 1. So sorry, I went to the horizontal to the right. And then we have a horizontal asymptote and a vertical asymptote here. And the thing to remember is that the shifts right here will help you to know which way to shift the graph itself. So we had the this one shifted 2 to the right. So that's why this asymptote came over to x equals 2. And then this shifted down 1, and that's why this asymptote is y equals -1. It's written right here, and we shifted down. Okay. Red in there is the 2 dots of where my points were my original thing. So I wanted to make sure that I went down 1 over 2. But again, draw your asymptotes first. And you can see where you should plot your points for the rational equation. Now, back up here at the notes. The first thing I want to do is I'm going to do each part of the notes separately. So the first one we're going to do the function of the absolute value of the function. And if you think about this, that means every time I put something in the function, whatever value I get for y, which is f of x, it's always going to turn out positive. Always going to turn out positive. So if you think of that as you look at it and understand what this is actually telling you like this, then you'll know that, okay, that means everything has to be above. Okay, it's all going to reflect up. So what the kind of the steps that I have for this is first graph the original in pencil. Okay. So after you graph the original in pencil, you're going to reflect. The second thing we're going to do is reflect all y values over the x-axis. Because remember, everything's positive now, so nothing is ever going to be a negative y. You're never going to get a negative y answer. Everything is going to be a positive to that absolute value. And so the third thing you're going to do after that is you're going to erase the graph below the x-axis. Okay, so what I'm going to do, we're going to do that information with everything that we have done so that we don't have to worry about, so that we understand, hopefully get a good flow of it. The only thing I want to remind you here is that all y values are positive at this point when you do this. So the first thing it tells you to do is actually graph the original function, which is this one that's on the left here. But what I'm going to do is I'm going to make sure that I have points, so I understand that when I plot them, I really do better personally plotting the points. So if I write them out, this one is 1, 2, 3, -3. This is 0, 0, 3, -2. Then we have 4, 0, and then 6, +1. Okay, so I've recreated the graph over here, and so now what I need to do is reflect all y values that are below the x-axis over the x-axis, and that makes all the y values positive. So just think about the y values changing to a positive number, then you'll see what you need to do. So the highlighted part is what I need to flip. So I need to do this part here, as well as this part here. So if I look at the points, this down here was a -6, -4, and so the y value needs to be positive. So now I should go up to -6, +4. So here's -6, 1, 2, 3, 4. Oops. So that's -6 now, +4. So the y value has changed the opposite sign. So same here. I'm just going to flip this one up. It's supposed to go, it's 3, -2, so now it's going to be 3, +2, 1, 2. And then it's going to be 3, +2 now. And then we're just going to connect this to this. Put that there. Then down here. Okay. And then now we erase anything below the x-axis. Now we have a graph. It looks like that. And then if you want to make it all in color, you can, but my new graph looks like this. Okay. Let's go down to number 2. Number 2, it tells us to graph the original, what we have on this side over here on the left. So I will graph those points and come back. Okay, so I've graphed the graph from to the left of me, and now I need to reflect anything that is a negative y value. So I'm going to have to flip up this right here. All of that. So now what I'm going to do is I want to look at what the point is below the points, so I know which one how I can do when I go up there. So this point here was a 1, a -2. So if I want to flip up, and then this point was a 2, -3, and this point was 3, -2. So all the x values stay the same, but the y values change to a positive. So this needs to go up to a 1 and a +2. 1, 1, 2. This point goes to a 2 and a +3. 1, 2, 3, and 3, -2. No, you don't have to write all those points. Just help you to remember what they are and so forth, so it reflects. So now what you want to think about, though, is you're going to think about, I'm going to zoom in on this. We're talking about reflecting from the x-axis, okay? So we want to look at this point right here is a point on the x-axis. So this is coming to this point, stopping there, and has to go back up to that vertex and come back down to the x-axis, and then it goes off this way. Okay, so And then now we erase everything that is below the axis. That's all. I'm going to get rid of all those numbers too. Okay, and if you want to make your graph all one color, so we had these points. Okay. So now let's go look at the cubic. So I want you to recreate the graph from the left onto the cubic, and we'll jump back in here in a second. Okay, so here's the recreated graph. There's only a little section. I mean, it does go down a lot farther down here if we extend this out a little bit more. There's a section that goes down this way. I'll do that a little neater. But when we do, we think about it, we just have that little bit that's got to come back and flip back up. It's going to reflect over the x-axis, okay? So, again, the highlighted parts, we need to get rid of this. So if I reflect that up, I don't really have points. I could go in there and find points if I want to find a point. If I say, okay, what is x when x is -2? Put in here and find a point, but I really don't have to think about that. All I gotta do is at this point right here at the x-axis, I have to flip up. So it goes here. It's just like a nice little thing. This flips. If you think about this, is going to flip up and it's going to go in this direction. Okay, so think about that being flipped over that, and then we erase the denominator. And then we're done. And you can make it all one color if you want. Let's go to number next. I don't remember what number it is, but okay, for this graph, still want you to list your asymptotes and state them, because the biggest thing is that knowing that that they're still going to be the same, maybe they'll change, finding them and so forth. This asymptote does not change. Okay, so with this asymptote not changing and so forth, so now we can just leave it there. It's going to still be part of the graph, and so now we got to reflect what is what's below the x-axis. So this is all below the x-axis right here, just this part here, okay? So if you notice, it'll flip up. It's going to be right there on the x-axis, and we flip it up. So let's just make sure that we have a nice, smooth flip. Okay, so flip it here at this point. It's going up. So see how it just still gets close to the asymptote, but it's flipped up. So now we're just going to get rid of all these pieces down here at the graph, leave the asymptote there, and there's our new graph. I want to make this a little bit all the same color. So now with this, flipped over that. Okay, let's go to number 11. Okay, so I'm drawing the original picture. The thing is, I want to make sure that here's where the graph crosses here, goes down, and then the other spot's right here, crosses and goes down there. Okay, with this graph, this is the original from the left, and so now we have to think of the absolute value part. So now we have everything needs to be reflected over the x-axis, everything below there. So if I look at what's below, all of this is below. Don't worry about the vertical asymptote. The vertical asymptote is not going to change. It stays there. We don't get rid of anything. It's just a line that's imaginary. Remember, it's imaginary. It doesn't really exist, but it can just stay there. And it's more the other parts that we need to worry about. Okay, so if you notice everything below there, even the y equals -1 line has to be moved up. Okay, so if that's reflected over the x-axis, it will go up to y equals 1. So now you have a new asymptote here. So you have y equals 1 is your asymptote. The other one is x equals 2 still. So make sure that you write this. This is your horizontal asymptote, and there's your vertical asymptote. just going to do that for now, VA and HA. Okay, so now that's up there. So let's look at this graph down here. This graph has to shift way up here. So it's going to shift, and the point that we have here is going to move to, let's do this. This one will move up here. Okay, that means it's going to go this direction, and here. Get close to the asymptote. Don't cross that number line. Be very careful. Oh, darn. Draw that back in. Doesn't let me do an undo on here. So, okay, so now it's going to go that way. Okay. Now, so that one's done. Get rid of that. We get rid of this asymptote over here on this side. And you got to look at this other part, okay? Sorry, I got rid of part of that. Now that little part is underneath, okay? Now when it reflects up, if you notice, this graph is crossing a horizontal asymptote, the red part of the graph. We're allowed to have that. When you have the thing that you can do in mathematics, graphs can cross the horizontal asymptotes, but they can never cross the vertical asymptote. So what I'll do is I'll write that in a second. So that means that I can actually take part of this graph where it's reflecting right here, and if this is going down towards my asymptote, and this is going to flip up and go towards this part of the asymptote. Okay? And again, it's just because those values are positive, there's nothing that can be down there. So now I'm going to erase the rest. I'm going to go ahead and erase this one because it's maybe. That's better. So all that's gone, so that's what the graph looks like, okay? I'm going to go back and draw this asymptote back. Okay, so and we'll note, okay? Graphs may cross horizontal asymptotes but never vertical. Okay. Okay, so here you're at the top again. If you notice again, we're taking the absolute value of the values of x before we substitute them in and find out what y is. And so the rule on this one, again, we're going to do the same thing. We're going to graph the original one we started with, or graph the original transformation in pencil. So you can do the same thing we did here. It's going to be the same directions down here. Okay, so number 2 tells us that we need to, or directions will tell us to erase the left side of the y-axis. So the last step would be to, we're going to reflect the rest of the graph over the y-axis. And remember, if you reflect over the y-axis, your x values change. Okay, so let's go ahead and graph this on here, original, from over there. 1, 2, 3, 4. Okay, so now we have this graph here. Okay, and they said erase everything on the left of the y-axis. go here, and I'm going to erase all these parts. Again, all these values are going to be like, this is more actually like the absolute value equation itself. You take the absolute value and you're still going to wind up in a positive area. So that's what's really happening here. So what we'll do is now you just reflect it. So every value that's there, you're going to reflect on the other side of that y. So let me plot my points slightly bigger. So this is at 3, -2. So this is going to go 1, 2, 3, -2. And then that other one's going to be at 4, 1, 2, 3, 4, 0. And then we have 6, +1. And then this point stays the same. So we're going to connect this here and there. Okay, so I recreated the original image over there on the quadratic. And so now I'm going to follow the directions. And the first thing it says to do is to erase the left side of the y-axis. So anything on the y-axis is just this part right here for me. Okay. And then now what we're going to do is we're going to reflect everything on the y-axis, on the right side onto the left side. So this point stays here. This is going to reflect 1, 2 that way. And so that'll be 1 down over here. Nice little quadratic, which makes it easy to reflect. So this is 1, 2. So we go up here, we go 1, 2. And there's our reflection. And so now we're just going to graph it in. I know I didn't go higher up, but you can just shorten the other side if you want. Okay, so now let's go to the absolute value of the cubic. So I recreated the graph. I'm going to now do the second step, which is to erase the left side. And then now we're going to reflect. Okay, so reflect. Think of this point here as the same. It's not going anywhere, but this point over here reflects here. And then we just go down. And there's your graph. All right, I'm going to go down to the next one, which is the logarithmic, natural log. So here's the natural logarithmic graph. So the directions are now to erase everything on the left side. So everything here, and then everything here. Okay. Now when you graph this and you mirror it, it is actually kind of a curving a little bit. So we're going to curve this side a little bit. Best we can. Okay. The reason it works for us is because when you take the absolute value of this, every value that you have is positive or negative will be positive. So inside that little parentheses will never be a negative. So we're allowed to graph it like this. We don't need the asymptote anymore. Okay, go graph the next one. Okay, so if you notice, I've only partially graphed this. The only thing I want to talk about is that when you have, again, something denominator that's a variable, we want to determine if there is a domain restriction. We already know that it can't be 2, okay? But we did it based on this, x minus 2. There is no absolute value with this x, but it's x minus 2, so we knew it was 2. So now we have to understand there is another one. So when you take the absolute value, the denominator, and we set equals 0 like we'd normally solve, we know that 2 can be an answer, but what other value can we put in there that will make this denominator 0? Well, -2. Because if you substitute -2 in here, you're going to get a positive 2, and then 2 minus 2 is 0 again. So check for that before you just disregard anything else to be added to that, okay? So now I'm going to draw the asymptote at that spot, which was at x equals -2. Now I'm going to go ahead and draw the graph now. The original graph before I do any erasing. Now, I said no, so we're going to erase the things on the left side. Now we're just erasing the graph on this one. We cannot get rid of the asymptote because we already shown right here, okay, that it needs to be there because of this we did up here. Okay, we don't want the denominator to be equal to 0. So now let's just erase the graph, okay? So let's erase the graph. I'm not going to erase the asymptotes at all. I'm just erasing the stuff on the left side. Okay, so now I'm going to reflect. I'm going to reflect this part here first at the top. I'm going to reflect this first. Okay, so if I reflect that over, this here point becomes here, and then this is getting close to asymptote, so we get close to this asymptote, come up and get close to the other asymptote. Okay, now again, so this part over here, we're going to reflect. So it starts here, there's a point here, so it comes up a little bit. It does go up a little bit and then comes down. It's not very tall up there, but it comes up a little bit. Okay, so this actually should be here. So, and so now I'm just going to draw it all in one color down here so we can see what happens. It's a little too much up there. The thing is, when you do look at this graph, if you have something down here, you shouldn't have anything up here, okay? So what happens with this graph, if you come from left to right, this graph goes up this way, it jumps the asymptote, and then it's coming back from, but it's down here, coming this way, it's got to connect to the next part of the graph, jumps down, so it comes up from the top and goes down this way. So again, goes this way, jumps over that, comes up from the bottom this way, jumps the asymptote and comes down.